Hello YouTube and welcome back. I am Benjamin Williams and today we're going to be doing another lab within Boson NetSim. Today's lab is going to be on configuring point-to-point OSPFv2. So let's go ahead and read our objective for this lab. It says a point-to-point lease line is one of the most common wide area network connections. This type of connection uses a serial interface to connect through a service provider to another serial device at a remote location. Open shortest path first, OSPF, behaves differently over a point-to-point link between routers than it does over a point-to-multipoint or local area network link. In this lab, you will configure OSPF over point-to-point links, okay? So if we take a look at our topology, we see that we have two point-to-point links from router 1, one to router 2, and one to router 3. And then router 2 has its own subnet, and router 3 also has its own subnet. And both networks have their own individual switches as well, okay? So let's take a look at our commands that we're going to be using for this lab. We have configure terminal, which enters global configuration mode for privilege exec mode. We have enable, which enters privilege exec mode. We have end, which ends and exits configuration mode. We have exit, which exits one level in the menu structure. We have interface type number, which changes from global configuration mode to interface configuration mode. We have IP OSPF process ID area ID. This places an interface in a specified OSPF process and area. We have network address, wildcard mask area ID. This activates OSPF on a specified network and places the matching interface in the specified area. Okay. We have ping IP address, which sends an ICMP echo request to the specified address. We have router OSPF process ID, which enters router configuration mode for a OSPF process. We have show interfaces interface name, type, and number. This displays detailed information about an interface. We have show IP interface brief, which displays a summary of interfaces on the device. We have show IP OSPF. This displays information about the OSPF process running on the device. We have show IP OSPF interface type number brief. This displays OSPF interface information. We have show IP OSPF process ID area ID neighbor. This displays OSPF neighbor information. And we have show running config, which displays the active configuration file. And we also have an IP address table in case we need to refer back to this table. It includes all of the devices, their interfaces, the IP address on each interface, and also the subnet mask. All right, so we're going to keep our lab topology in the top left. We're going to be doing our lab readings in the top right. And we're going to be doing all of our configuration down here at the bottom, okay? So task number 1, it says configure OSPF. It says in this task, you will configure OSPF on router 1, router 2, and router 3, thereby establishing OSPF adjacencies over point-to-point links. In addition, you will learn how OSPF adjacency over point-to-point links are different from adjacencies over point-to-multipoint links. All right, so number 1, it says from PC1, attempt to ping 10.10.200.100. The ping should fail because no routing protocol has been configured on the network. All right, so that means that router 2 will not have a network to reach PC2. And because of that, when PC1 sends that traffic to router 2 is going to drop that traffic because it does not have a destination to that network. So if we do a ping to 10.10.200.100, oops, I put a slash, didn't mean to do that. As you can see, our pings are responding back saying that the destination host is unreachable. And that is because router 2 does not have a network path to that network, okay? So number 2, it says on router 1, issue the command to display detailed information about the serial 00 interface. What encapsulation protocol is in use by the interface? Why is it important that encapsulation protocols match on each end of a point-to-point link? So if we go to router 1, and we're here now, let's do an enable and let's do a show interface serial 00. All right. And if we take a look in here, let's try to find the encapsulation mode that we're using. Yep, right here. We can see encapsulation PPP. So we're using point-to-point protocol. Okay. And it's important for both of those to match on both sides of the point because that is how we're encapsulating our data, and also de-encapsulation our data. So that needs to match on both ends so we can send traffic between router 1 and router 2. They have to have the same encapsulation mode, or traffic will not be able to be sent between that link. Okay. All right. So number 3, it says on router 1, issue the command to display a brief, is there a command to display a summary of interfaces configured on the device? Based on the output, what IP address do you think OSPF will automatically select as router 1's router ID? So if we do a show IP interface brief, we can take a look and we can see that the loopback 0 IP address is going to be router 1's router ID. And that is because OSPF takes the highest loopback interface's IP address as the OSPF router ID if a router ID is not already configured. If there is not a loopback 0 interface, then it will use the highest interface IP address on the router. Okay. So right here, as you can see, we are going to use that loopback 0 interface. All right. So number 4, it says on router 1, configure a OSPF router process with an ID of 10. All right. So let's do the router 1. We'll do a configure terminal. Let's do a router OSPF 10 for the process ID of 10 and hit enter there. All right. Number 5, it says on router 1, issue the command to display information about the OSPF processes running on the router. Which IP address did OSPF select as the router ID, and why did it choose it? So if we do a do, I got caps on. Let's do a do show IP OSPF, and we can see that the router selected 1.1.1.1 as the router ID. We see ID 1.1.1.1. And it chose this because, like I said, OSPF needs to have a stable IP address. And we know that a loopback interface is likely not going to change on a router. A physical interface status can change, but the loopback interface is always going to be in the upstate. And OSPF wants a stable IP address when it's conducting itself throughout the network. So router advertisements can be sent, and it just basically needs a stable IP address to conduct itself properly within the network. So it will use a loopback interface before it uses a physical interface. So that is why it used this IP as the router ID. Okay. So number 6, it says on router 2, configure an OSPF router process with a ID of 20. What other configuration tasks needs to be performed on this router in order to enable the router to establish adjacencies? So on router 2, we can come over here now. We can do an enable, configure terminal, router, OSPF, and we give context-sensitive help. We want to do a process ID of 20 and hit enter there. All right, and it says what other configuration task needs to be performed on the router in order to enable the router to establish adjacencies. So we just did both of the processes on router 1 and router 2, but we need to enable the interface between those two routers that are on the same network, so OSPF, so an OSPF adjacency can form. Okay. So on number 7, it says on router 3, configure a OSPF router process with an ID of 30. So let's go to router 3. Let's do an enable, configure terminal, router, OSPF, and we give context-sensitive help. It wants us to put in the process ID. Let's put in 30 and hit enter. All right. Now, number 8, it says on router 1, router 2, and router 3, place the device in interface configuration mode for the loopback 0 interface. Configure the correct OSPF process for each interface. In addition, configure the interface to operate in OSPF area 0, which is also known as the backbone area. Do the routers form adjacencies now? Why or why not? So if we go to router 1, and we do we do an exit. We want to go into interface configuration mode for loopback 0. We want to do an IP OSPF. We want to give a process ID of 10 because that is what we configured on this router, and we want to do it in area 0. So area 0 is the backbone area. So we want to place this loopback 0 interface into area 0, and the process ID for this router is 10. So let's hit enter there. That looks good. Let's do the same thing on router 2, but just give a different process ID. Let's do an exit. Let's go into interface loopback 0. We want to do an IP OSPF20 for area 0. All right, let's go to router 3. Let's do a exit. Let's go into interface configuration mode for loopback 0. Let's do an IP OSPF 30 area 0. Hit enter there. All right. So it says, do routers form adjacencies now? Why or why not? And they have not. And that is because we configured the loopback 0 interfaces to participate in OSPF. And we know loopback interfaces are internal, basically internal interfaces. They do not share a link. Loopback interfaces do not share network links. So because of that, adjacencies are not going to form. We have to have both sides of a router's connections needs to be configured with OSPF for an adjacency to form. And we have not configured that. All we did was enable the loopback 0 interfaces to participate. And because of that, those are internal to each device. So that is not a connection between two devices. So because of that, we do not have OSPF adjacencies. So we need to configure networks on each device that are connected to one another to participate in OSPF for an adjacency to form. Okay. So on number 9, it says on router 1, place a device in OSPF configuration mode for OSPF process ID of 10. From this mode, configure both the serial 00 interface and serial 01 interface to operate in OSPF area 0. Use a single command to complete the configuration. What wildcard mask did you use and why? So first on router 1, I want to go down to the IP address table. We can see that the serial 01 has an IP address of 203.0.1.113.1, and serial 01 has an IP address of 203.0.113.5. So what we want to do is we want to encompass both of these addresses into one command. We can see that both of these addresses are using a /30 network mask. So we want to do a /29 to encompass both of these addresses. So we're going to give an IP address of a /29, which would be a 0.0.0.8, an 0.0.0.7 as a wildcard mask, and it'll be a 248 in the last octet if we were doing regular dotted decimal. All right. So let's go to router 1, and let's do an exit. Let's go into router OSPF for process number 10. We want to do a network of 203.0.113.0. We want to do an 0.0.0.7, and we want to do it for area 0. All right, and hit enter there. So we did an 0.0.0.7 to encompass both of these IP addresses. And we were able to do that because we did this wildcard mask right here. Okay. So number 10, it says on router 2, place the device in OSPF router configuration mode for the process ID of a 20. From this mode, configure the serial 00 interface to operate in OSPF area 0. As the routers form an OSPF adjacency, consider which router do you think OSPF will elect as the designated router and why. So if we go to router 2, and we do an exit, we go into router OSPF for process number 20. We do a network of 203.0.113.0.113. And if we take a look at router 2 serial 00 interface, it has an IP address of 203.0.113.2. And it has a /30-bit subnet mask. So we want to do that network 203.0.113.0. We want to do a 0.0.0.3 for a /30, and let's do an area of 0. All right, and hit enter there. And the last question was which router will be the designated router. And if we take a look at our topology, we can see that this is a serial connection. So if we remember, OSPF does not elect a DR and BDR for serial point-to-point links. So that is a trick question. There will be no DR election on this link, okay? So on number 11, it says on router 3, place the device in OSPF configuration mode for the OSPF process with an ID of 30. From this mode, configure the 001 interface to operate in OSPF area 0. Use a wildcard mask that is equivalent of the subnet mask configured on the interface. So, if we go back down to our IP address table, and we can see that our adjacency came up with router 1. We can see that the router ID is right there, and we're from loading to full. So we're sharing identical LSDBs now. All right. So on router 3, let's go to router 3 now. Let's do an exit. Let's do a router, OSPF for a process ID of 30. Hit enter. And we want to do a network of 203.0.113. If we take a look at the 001 interface, we can see it has an IP address of 203.0.113.6. So this would be 203.0.113.4. We want to do a subnet mask of 0.0.0.3 for area 0. All right. And we want to do a enter there. All right. So number 12, it says, on each router, display the neighbor relationships. What do you notice about the state column in the output? So before I do this, I want this adjacency to come up with router 1. So let's give it some time. We know OSPF for point-to-point links takes a little bit longer than it does for broadcast links. It takes 30 seconds. There it is. It takes 30 seconds for serial point-to-point links, and takes 10 seconds for Ethernet links. Okay, so we see our adjacency came up. So now if we do a do show IP OSPF neighbor, that's what it wants us to do on each device. Let's do it over on router 2. Let's do a do show IP OSPF neighbor. All right, and let's do the same thing over here on router 1. Let's do a do show IP OSPF neighbor. All right, we can see that it says, what do you notice about the state column in the output? If we go to the state column, we can see that we're in the full state, which is what we want, but we do not have any DR and BDR elections occurring. That is a dash there, and that is because we are dealing with point-to-point links in this lab, as you can see from the topology. We're not dealing with Ethernet links. We're dealing with point-to-point links, and as we know, DR election does not occur with point-to-point links. So router 2 is going to be the same thing, full and a dash, and same thing for router 3, full and a dash. All right. So on number 13, it says on PC1, ping PC2. Is the ping successful? Let's go to PC1 and try that ping again. And we are getting a destination host unreachable. And that is because we configured OSPF for the networks between these routers, but we have not configured OSPF to participate on router 2's subnet down to switch 1, and we have not configured OSPF on router 3's subnet down to switch 2, which contain both PCs. All right, so we need to enable these interfaces on router 2, the Ethernet link, and the same thing on router 3. We need to enable these links to participate in OSPF so these computers can communicate. All right, so number 14, it says on router 2 and router 3, ensure that each device is in OSPF router configuration mode for the locally configured OSPF process. Next, configure each router's Fast Ethernet 1.0 interface to participate in OSPF area 0. Why do you not receive OSPF adjacency messages after you complete this configuration? All right. So if we go to, we want to do it on router 2 first. So now I want to do a network. Let me go to the address table as well. So we want to configure the Fast Ethernet 01, which has an IP address of 10.10.200.1 and a /24-bit subnet mask. So we want to do a network of 10.10.200.0, 0.0.0.255 for area 0. All right, let's do the same thing over here on router 3. Oops, I think I did that wrong. Okay, I did that on, this is supposed to be on router 2. So router 2 has a network of 10.10.100.1. So I want to do a node network of 10.10. 200.0, O.0.0.255, area 0. Let me negate that. And I want to do a network of 10.100.0, O.0.0.255, area 0. All right, and I want to do the 200 on router 3. You can see it's fast Ethernet 0 and 1 IP address is 10.10.200.1 with a /24-bit subnet mask. So I want to do a network of 10.10.200.0, O.0.0.255 for area 0. Hit enter there. All right, and it says, why do you not receive OSPF adjacency messages after you complete this configuration? Well, if we look at our configuration, our adjacency is with router 1. We do not have any connection to another router down here on router 2. So our adjacency is already up on router 1, so we will not be getting any other adjacency messages occurring. All right. So number 15, it says, on each router in the topology, verify that the OSPF neighbor relationships are up and full. What do you notice about the neighborships between the routers as it relates to DR and BDR elections, basically? And we already kind of looked at that. We can see it right here. We can see that DR and BDRs are not elected on these links. And that is because we're dealing with serial point-to-point links, okay? So serial point-to-point links do not do any type of router election, all right? Because we're dealing with two routers. If we were dealing with an Ethernet link, as we know, multiple routers can communicate over that link. And because of that, with OSPF, we can have a lot of traffic traversing the network. So to keep the traffic down, we elect one router as the DR, and we have a backup, which is known as the BDR. So if the DR goes down, the BDR will take over as the main router that sends out all of the information for the network. All right, and that brings down usage for OSPF within our network. All right, which gives us more bandwidth to do and send under other traffic. Okay, so it says now from PC1 attempt to ping PC2, the ping should succeed. So let's try that. And yes, we are now getting replies. So now this ping is successful. We're getting replies. Before it was not. So we configured a route on router 2, a dynamic route, and we shared those dynamic routes in this network. So we are now able to communicate from one network over to another without being directly connected. All right. So that looks to be the end of this lab. Let's hit grade, and hopefully we did everything correctly. And we did. So I appreciate you guys for watching this one, and I will see you in the next one.